Good day, students. We will learn the continuation topic of method of images. The method of solving the boundary value problem was invented by Lord Kelvin to determine the values of E, D, V and rho s. Now the figure 1 speaks about the conducting plane above which the charge as point charge, line charge and a volume charge are placed. Now if we replace this conducting plate or the plane by an equipotential surface with V equal to 0, plus Q is denoted by minus Q, plus rho L by minus rho L, plus rho V by minus rho V. So, the conditions to be satisfied for the boundary condition are Laplace equation is to be satisfied first, and the image charge distribution must be located such that V on the conducting plane is either 0 or constant. These are the conditions to be satisfied. Now the same analysis with the point charge distribution we are going to proceed with. We have chosen the point charge distribution. The point is Q 0, 0, A. Rectangular ordinate system we are speaking about. This is above the ground plane, V equal to 0. Now the point charge is emanating the field lines. The field lines are emanated on either side of the ground plane with V equal to 0. The same charge. Now the image point charge plus Q is replaced by minus Q. So we have chosen a point P at some distance from charge Q from minus charge Q. So 0, 0, A, this is 0, 0, minus A. Based on this only, we are going to prove that plus Q is equal to minus Q. So the point charge plus Q is equal to minus Q. Our first step is to find out the vectors, R1 vector and R2 vector. As we know that R1 vector is defined between the points 0, 0, A and x, y, z. So x minus 0, y minus 0, z minus A will be R1. Likewise, x minus 0, y minus 0, z minus of minus A will be R2 representation. So first step, I am doing the equation of R1 vector and R2 vector. I am naming it to be equations 1 and 2. Next, let us find out the electric field intensity due to the point charge. We know by definition E is equal to Q by 4 pi epsilon R square of AR vector. In this diagram, it is due to two charges. So, it is due to plus Q minus Q. So, E due to plus Q is E plus, E due to minus Q is E minus. So, Q by 4 pi epsilon of R square will have as such R1 vector, AR1 vector is replaced by R1 vector divided by R1 value. So, it becomes R1Q. Same way for E minus. So, E is the sum of E plus plus E minus. I am just substituting both the equations, naming it to be 5. After which, I am substituting the value of R1 from here and R2 from here. Simplifying the equation with the conditions that at the surface of the conducting plane Z is equal to 0. When Z becomes 0, this term will be 0, this term will be 0, this term will be 0. Upon simplification, the equation reduces to the form of E equal to Q by 2 pi epsilon naught of A Z vector, this value. Actually, why we are saying this to be a normal component? When we view in this equation, we have an AZ vector, not AX vector, AY vector. So, the component of X and Y vector does not exist. We have only the Z component. Therefore, it is said to be normal to the plane. So, this confirms the condition of E to be normal to the conducting plane, because we have only AZ vector. But by definition of boundary condition, in the previous derivation we have seen D normal is equal to rho s. But by consecutive relation, I can write D normal equal to epsilon into E normal vector. So rho s becomes equal to, comparing these two equations, rho s becomes equal to epsilon naught of E normal vector. Now substitute E normal vector from the equation 7 into this 8. So rho s becomes equal to epsilon naught into E normal. Upon simplification, I get an equation number 9. Now, using Gauss law, we know that integral d dot ds is equal to charge enclosed. Let me have charge to be as such. D is replaced by rho s. Okay. So, integral rho s ds equal to charge enclosed. As it is rectangular ordinate system, the point charge is assumed in. I am choosing the surface to be equal to dx dy. I have only az component here. So, the surface element is dx dy of az vector. So, az dot az is equal to 1 we know. So, Q becomes equal to this equation is called as the equation number 10. Now, I am going to transform this equation in the Cartesian ordinate system into cylindrical ordinate system. Because it is a surface analysis, I am moving on to the surface condition of cylindrical. So dx dy can be replaced by rho d rho d phi. Same way rho square can be replaced by x square plus y square. So I am substituting these two values in equation 10 to get the value of 11. We know phi ranges from 0 to 2 pi, rho ranges from 0 to infinity. Again segregate the term. d phi I have taken separately 0 to 2 pi, integral 0 to infinity of rho square plus a square I have taken up. Power minus 3 by 2, rho of d rho remains same. Make use of the mathematical substitution, rho square plus a square equal to u. So we differentiate it, 2 rho d rho becomes equal to du. Rho d rho can be replaced by du by 2. So all substitutions I am making, I am having this term minus qa divided by 2 pi as such. Integral d phi is phi. Limit is 0 to 2 pi, so it becomes 2 pi. And u power minus 3 by 2 du by 2. Again that 1 by 2 I have taken out. Integral u power minus 3 by 2 du. So upon cancellation of all necessary terms, it becomes minus qa divided by 2. The integral of this concept is nothing but equal to minus 2u power minus half. Limit is 0 to infinity. So when we substitute the upper limit minus the lower limit, it becomes a and a are cancelled out. 1 by infinity is 0, so you are left out with q equal to minus q. This equation has proved that by the method of images, the charge q has induced another charge of opposite polarity in the conductor. So this is called the method of images. Thank you.